What's up, guys? All right, so today we're going to solve rational equations. And before we start, I just want to show you a couple things that you already know. If I have something like this, 1 over 10 equals x over 10. Can you tell me what x equals? It's not a trick question. Of course you can. You can tell me x equals 1, right? There is nothing hard about that, right? That's because the denominators matched. If this was 1 over 9 equals x over 10, there's no way you'd be able to tell me x that fast, okay? So the point of the story here is, as long as the denominators match, you don't even need to look at the denominators anymore. You know that x equals 1. So if the denominators match when you're solving rational equations, you can just get rid of the equal sign, okay? We could do something simple like this. If I have 3 over x minus 1 equals 9 over 4x plus 5, okay? The denominators don't look the same, so you can't just go 3 equals 9. That doesn't make any sense. But as long as the denominators do match, you can do that. So what would we have to do? Well, we need to make the denominators match. So this guy right here is an x minus 1. It can't be factored, so put parentheses around it. This is a 4x plus 5. That can't be factored either, so put parentheses around it. Okay, now let's make our denominators match. This guy's got an x minus 1. This guy doesn't, so it needs 1, x minus 1. Okay, so put an x minus 1 up here. This guy has a 4x plus 5. This one doesn't, so this one needs a 4x plus 5. Okay, and put one up here, 4x plus 5. Okay, and now the denominators are exactly the same. See, x minus 1 times 4x plus 5. X minus 1 times 4x plus 5, they're exactly the same. Just like over here, the denominators were the same. You don't need them anymore. So we can cross them off if you want to. You can do that if you want. Okay, but now look what we have. We have 3 times 4x, that's 12x. Okay, 3 times 5 is plus 15 equals 9x minus 9. Okay, and now you can just move the 9 over, so you get 3x equals, subtract, what is that? Subtract 15 to the other side, so we get negative 24. Divide by 3, x equals negative 8. Okay, so that's the idea. Get the denominators to match, and you're good to go. So let's do this. Let's use, I guess, my notes show part A, but I'm going to skip part A and just go straight to part B, okay? And we're going to use common denominators. We're going to solve using common denominators. And we need to always check our solutions. Okay, let me sharpen my pencil real quick. Let's do this. I'm going to do as many examples as possible. All right, so here's our first one. Example. We have 1 minus 8 over x minus 5, okay, equals 3 over x. Now, one of the things is, when it says check solutions, if I get a solution that says x equals 5, well, right off the bat, I know that that's impossible. Because watch, if x was 5, what's 5 minus 5? That's 0. And 8 over 0 is undefined. So 5 can't be a solution. Similarly here, if x is 0, if I work all this out and I get x equals 0, if I plug that in here, 3 over 0, that's undefined, so that's not an answer. So I know 5 and 0 are not good answers. So that's one of the ways we're going to check our solutions. All right, so here we go. This can't be factored, put parentheses around it. Okay, this is a 1 over 1, right? So I'm just going to put over something. Now remember, this guy needs an x minus 5, so put an x minus 5 and put an x minus 5 here. Okay, this guy needs an x minus 5, so x minus 5 here, x minus 5 here. Okay, this guy needs an x, so put an x, and this guy needs an x, put an x, put an x. Okay, all right, so now all of our denominators are exactly the same. They all have x minus 5 times x. X minus 5 times x, x minus 5 times x. So now I don't need them anymore. I could cross them off. All right, so now I get 1 times all that. So that's really x times x, that's x squared, okay, x squared. X times minus 5, that's minus 5x, okay. Minus 8x, so minus 8x, equals 3x minus 15. All right, I notice we have an x squared here. I have x's, I have constant terms, so I know I'm gonna probably have to use the quadratic formula or hopefully factor. Okay, let's get everything to one side. So I have x squared. I have negative 13x's, minus 3 more is negative 16x's, okay? Add 15 to the other side, so plus 15 equals 0. Well, it looks like we can factor it. X and x, I need a 15 times a 1, and if they're both negative, negative 15 times negative 1 is positive 15, and negative 15x minus 1x is negative 16x. So I know that x equals 15 and x equals 1. All right, and let's check our answers. You know what, I blew it. I shouldn't have written all of my scratch work at the start there. It makes it really hard to check our answers. In the future, let's not put all of our work here on the original. Let's maybe copy one more step. It just makes it really hard to check your answers like that. All right, so I'm not going to check those. Let's try another problem. Let's see if we could do a few more. All right, so we have 6. Let's see. I'll do this one. 7 over 2 plus 3 over x equals 3. Okay. All right, so I know right off the bat x can't be 0. Okay, can't be. All right, so I'm going to recopy this. 7 over 2 plus 3 over x equals 3 over something, right? All right, well, this guy needs an x. This needs an x. This guy needs a 2, so I'm going to multiply by 2. And this guy needs a 2x, so multiply by 2x. Okay, now all these guys cancel, and I'm left with 7x plus 6 equals 6x. All right, I'll subtract the 6x to the other side, so I get 1x. I'll subtract this to the other side, equals negative 6. Okay, so x equals negative 6. And I guess we could check it just for fun. I don't know, nothing better to do. Okay, I'll plug in a negative 6. So negative 6, 3 over negative 6, that gives me negative 1/2. Okay, 7 halves minus a half is 6 halves, and 6 divided by 2 does equal 3. So we're good to go, all right? So again, really, I think the only time that you need to check the solutions is make sure x is not 0 or x is not 5. All right, let's do some more. All right, I'll try to do 2 more, maybe even 3. Here we go. Let's do a crazy one. 6 over x minus 3, okay, equals 8x squared over x squared minus 9, okay, minus 4x over x plus 3. Now this one might look crazy, but it's actually not, okay? Because if you look, this guy right here is a difference of squares, and it factors into this, x plus 3 and x minus 3, okay? So let's go ahead and copy this again. Okay, so 6 over x minus 3, put parentheses around it, equals 8x squared over x plus 3, x minus 3, okay, minus 4x over x plus 3, put parentheses around it, okay. And what was cool about that factoring like this is now I know that this guy has both of those guys. This guy needs an x plus 3, okay, so x plus 3 up here. This guy needs an x minus 3, okay, so x minus 3 here. All right, we're good to go. The denominators match, so you don't need them anymore. Okay, get rid of them. You don't need them. So now we have 6x plus 18. Okay, 6x plus 18 equals 8x squared. Okay, now this is 4x squared, okay, minus 12, okay, but it's minus all that, so minus 4x squared plus, oh, I'm sorry, this is 4x times negative 3, so that's negative 12x, my bad. Okay, so then it's minus negative 12x, so plus 12x. All right, it's going to be quadratic, so let's move everything over. Okay, so 0 equals, so this is 8x squared minus 4x squared is 4x squared, okay, plus 12x. I'm subtracting 6x over there, so it's going to be plus 6x. Okay, so plus 6x, and then subtract 18, so minus 18. All right, everything here is divisible by 2, so 0 equals 2x squared plus 3x minus 9. All right, and let's go ahead and try to factor that. So 0 equals, hopefully it factors, if not, whatever, quadratic formula, 2x and x. 3 times 3, looks like, okay? So we have, Inside terms is 3x, outside terms is 6x. I need a positive 6x minus 3x to get 3x, so minus positive, okay? So x equals 3 over 2, and x equals negative 3. And let's check our answers, okay? If x is negative 3, what happens if I plug it in right there? What if I plug in negative 3? Isn't negative 3 plus 3, isn't that 0? And isn't anything over 0 undefined? So this guy is not a good answer. That guy does not work. You see why we have to check our answers? All right, let's try to do one more. Here we go. Example. Let's do this guy right here. 3x over x plus 1 minus 5 over 2x equals 3 over 2x. Looks pretty easy. Okay. Go ahead and copy it again. 3x over x plus 1. Or here, check it out. Here, let's not waste our time. Let's just do something like this. This might make it easier, okay? Just tell me what x can't be, okay? X cannot be, right, negative 1. X can't be negative 1, so x can't be negative 1. And here, x can't be 0, okay? So we already know what our answers can't be, okay? So go ahead, let's go ahead and mark up the original problem here. So this guy needs a 2x, so put a 2x, put a 2x. This guy needs an x plus 1. We need an x plus 1. And this guy needs an x plus 1 and an x plus 1. All right, we're ready to go. All right, so the denominators don't matter anymore. They all match. So we have 3x times 2x is 6x squared, okay, minus 5x, okay, minus 5 times 1 is minus 5, okay, equals 3x plus 3. All right, again, it's quadratic, move everything over. We have 6x squared. Minus 3x and minus 5x is minus 8x. Okay, minus 3 and minus 5 is minus 8, equals 0. Everything here is divisible by 2, so I'm just going to rewrite it. 3x squared minus 4x minus 4 equals 0. Hopefully it factors. If not, well, whatever. We'll use the quadratic formula. 3x and x. I'm going to go 2 and 2. Okay, the insides are 2x, the outsides are 6x. Negative 6x plus 2x gives me the negative 4x. So we got a plus, got a minus, and here we go. X is going to equal negative 2/3, and x equals 2. And both of these guys are different here, so these are good answers. Okay? All right, guys, that's it for me. Hope that was helpful, and I will see you soon. Peace.